Okay, Year 12, I'm about to do exercise 1206, which is annuities and geometric series without tables using our formulas. And exercise 1206 is just investments, which includes superannuation and geometric series going up. Now, I've had a lot of thought about this and about how to do this. And I've talked to colleagues, both within school and outside of school. And I've come to the conclusion that we're not going to, well, you can use the examples and you can go and see other teachers and use the example method that is shown in the textbook to solve these, but I'd strongly advise against it. The method I want to show you is the same method that we're going to use for reducing or for loan repayments. And I want to keep a nice consistent method for both types of questions. Whereas this method that they do here in this example here, it worries me because we talk about A1 being final amount, and I have some issues with that, and it's not representative of how we're going to do these with repayments, loan repayments. And also, sometimes in HSC questions, they ask you to find A1, A2, and A3 in investment, and I'll show you some of these, and it's not like that. So if you learn that method, you've got to be very careful and very smart about how you use it. Anyway, so I'm going to do these using a different method. Well, not a different method. When you look at the solutions in the back, it's weird because they show this method that they've got here, and they then do a different method in their work solutions. Anyway, I'm going to show you how to do it, and we are going to be using this formula, and we're going to set up a series. So let's have a look at it. The first thing you need to be wary about is when the money in this annuity is being invested. So here it's at the end of the year, here it's at the end of the year, here it's at the end of the year. In most of the questions, it's going to be at the end of the year. Sometimes, however, they can put it at the beginning of the year, which can cause some issues, but not if you're smart, as you all are, I'm sure. So question one, we're putting $1,500 at the end of each year for 15 years at 8%. So let's set this up. So the amount of money at the end of the first year, well, that's $1,500. That's how much is in the bank account or the super fund at the end of that year. There's no interest earned because it was put in at the end of the year. And at the end of the second year, that $1,500 will have earned 8%. So that $1,500 will be multiplied by 1.08. Plus, I put in, well, another $1,500 is deposited. We'll do one more. All this money here that was in at the second year, at the end of the third year, will have earned 8%. So that's all the money that was in at the second year, and it's all earned 8%. Plus, another $1,500 will have been deposited. Let's just expand that. 1.08 times those two things in there, and I get 1,500, and that's A3, times 1.08 squared, because of 1.8 times 1.8, plus 1,500 times 1.08, I'm going to put a 1 there even though I don't need to, plus 1,500. Now, let's do A4, but let's do it without putting brackets and expanding. Well, look at this. It's a series. Look at this. I've got 1500, 1.08 to the 2, 1500, 1.08 to the 1, and now 1500. So in A4, I'm going to have 4 of these, but it's going to be to the 3, to the 2, to the 1, and then just a 1500. So I'm going to have 1500 times 1.08 to the 3 plus 1500 times 1.08 squared plus 1500 times 1.08 to the 1 plus 1500. Okay, so you can see the pattern now. Got a cube there and a squared here. So the first term is 1 less than this term. I've got a 4 there, I've got a 3 there, and I go all the way down to just that last term. I can even, well, let's look at this. Let's factorise out the 1500s. All right? So I've got 1500, and then I've got 1.08 cubed plus 1.08 squared plus 1.08. I'm going to write 1, but you don't need to, plus 1. Please remember, when you take 1500 out of the last term, you're left with 1. And what you have here now is a series. And I'm going to write that the other way round. I'm just going to turn them all around so I've got the 1 at the front. So 1500, 1.08, 1 plus 1.08 to the 1 plus 1.08 to the 2 plus 1.08 to the 3. And there's my series. Okay, now I can keep doing this, but I don't want to go through and do this all the way. Can I see the pattern and just go now straight to A15? Yes, I can. 1500, 1 plus 1.08 to the 1 plus, I'm not going to write all the other terms, 1.08 to the 13 plus 1.08 to the 14. Because remember, this number is 1 more than this number. So what have I got? I've got 1500 times, this is a series where my first term is 1, my R is 1.08, and this is where you've got to be careful. How many terms are there? A lot of people will go, oh, there's only 14. No, there are 15, because you're starting at 1, or you're starting at 1.08 to the 0, or you're starting at 1. So you got 1 plus 1 to 14, you got 15 terms. So now, 1500. Now, because that's a series, I'm just going to use S of n. And that's what I said, you're going to use S of n over here. And then it's just calculator work. So, equals 1500 times A, 1, R to the n, 1.08, to the 15 minus 1 over 1.08 minus 1. And now I just go calculator work, 1500 times bracket, I don't need the 1, 1.08 to the power 1.08 to the power of 15 minus 1 divided by, I'm going to put this in brackets, 1.08 minus 1. 40,000, and I need to get my textbook up. Where are the solutions? Hold on. Question 1. $40,728.17. Yes, we are right. $40,728.17. Now, I've really stepped that out. You won't go through all those steps. You might skip 8 of the 4. You might be able to see it a lot more quickly. That's how I want you to do them. You're going to need to build it, and there are 14 questions here. You really need to put some time into it. The reason I want you to do this is because it's going to teach you good habits. So I'm going to do another one. I'm going to do a couple more, but here's what I wanted to show you. If we look at the work solutions, here it is here. And look, they did exactly the same as what I did. All right? Although they figured out the sum as a number, I wouldn't do it. I'd do it all as on my calculator. So even that, this is what I find strange. Even though they say to do it by another method in their example, in their work solutions, they do it just like I would and how I want you to. So let's have a go at another one. I'll do another one that's at the end of the year. And we'll do one that goes for quite a while. I might try let's do the birthday one. Let's do 5, Miguel. So over here, here's question 5. Miguel's mother invests $200 for him each birthday, up to including his 18th birthday. The money earns 6%. How much money will Miguel have on his 18th birthday? Let's assume that they're not putting money in when he's born. It's on his birthday. So how much money was it? It was 200, 6%, 18. So $200, 6%, and he turns 18 years. So on his first birthday, they put the money in, he's got $200. On his second birthday, he's got 200 times 1.06 plus 200. On his third birthday, he's got 200. I'm not going to write it out like I did before because I know what I'm doing now, times 1.06 squared plus 200 times 1.06 plus another 200. I'm going to factorise out that 200. I'm going to turn the 1 plus the 1.06 around. Sorry, that's squared. When it's put in at the end, this number and this number are always, well, that one's bigger than the one in the series. So on his 18th birthday, ... it'll be 200, 1 plus 1.06 plus ... 1.06. See if you're smart, 17, one less. And I always like to write this, A equals 1, R equals 1.06 and N equals 18. So on his 18th birthday, he'll have 200 times S of 18. 200 times, and remember S of 18 is A R to the N minus R to the N minus 1. Now I'm confused. R to the N, thank goodness. I was thinking of the term. R to the N minus 1 over R minus 1. So it's 1.06 to the 18 minus 1 over 1.06 minus 1. Calculator, I'm just going to use my back arrow. So it's 200, 1.06, 18, 1.06 minus 1. And was it question 5? That's right. So the answer is 6181.13. Yep. $6,181.13. And as you can see, as you get better at these, they're slightly quicker, but you still need to set them out like that. I know that, and if we look at the, can I move that? If we look at the answer, how did they do it? Exactly the same. They worked out Y1, Y2, Y118, so year 1, because they're writing year. I don't know why they're using Y. Most of the time people use A. I'm pretty sure they go to A later on. Come on, where are these work solutions? All right. But anyway, so let's do one more, and I'll do the beginning of a year. So here's the one, 7. 3,000 at the beginning of the year for 6 years, 5%. So here's question 7. Let's get that information again. 3,000, beginning of each year, 6 years, 5%. So 3,000, 5%, 6 years. So A1, well, you put 3,000 at the beginning, and that will have earned 5%. There is a difference. There's actual interest earned by the end of the first year. At the second year, you're going to have 3,000 will have earned 1.05 squared, plus another 3,000, which will have earned some interest as well. Now, here's the big difference. That number and that number are now the same. So we could keep going, but we can jump to 6 now. I'm going to have 3,000 times 1.05 to the 6 plus 3,000 times 1.05 to the 5. I'm not going to write down all the terms. Plus ... 3,000 times 1.05 to the 1. So I'll factorise out the 3,000. I'm going to turn this around. Now be careful when I turn this around. Before I got 1 at the end, but here I'm just going to get 1.05. 1.05 to the 1 plus 1.05 to the 2 plus dot 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 1.05 to the 6. So what have I got now? Here is a series where A equals 1.05, R equals 1.05, and N equals 6. Oh, it's terrible. So the amount will be 3,000 times S of 6. 3,000 times A 1.05 times 1.05 to the 6 minus 1 on 1.05 minus 1. So when I go to my calculator, I'm going to have to do this all again. So 3,000, I'm going to do this as a fraction this time. Doesn't matter. 1.05 times 1.05 to the power of 6 minus 1. And go down below and I get 1.05 minus 1. And I'm just checking the answer. 21,426 and 3 cents. That's right. 21,426 and 3 cents. Now, there are, and you're going to have issues. I think there are 14 questions. All right. I'll do another video for when people ask questions. I'll probably have to do one for 14. But yeah. Anyway, please make sure you set them out this way. Even that question 7, let's see how they did that. And if I go to question 7, oh, come on. It's not coming up. Question 4, 5, 6. Okay, so there's question 7. Look how they did it. Exactly the same way. Almost to the letter, except they found this value down here. When they find S of 6, see that S of 6? That, when you do, that S of 6 is a number, come on, that goes in the table. That's the number that goes in the table. That S of 6 or S of whatever is a percentage rate that an annuity would go into the table for. All right? So, but I'll do another video on that later. I want you to get started on these. Good luck.